Alrighty. So it does seem that my editing skills are acceptable, but I didn't want to push my luck, so I'm doing a new video for the try this one on your own. Alrighty, let's go back to Excel and get these guys typed in. So smelly candles. Alrighty, let's think about our A and our B here. So we're estimating the total cost of producing 800 ounces of wax. So 800 is probably the stop. So in my right here, my inequality, x less than or equal to 800, 800 would be the maximum. So think about when you do the antiderivative of the marginal, you're going back to the total cost. And the total is always from when you start to when you finish. So what value for A would be the starting amount of when we start producing? So yes, you guessed right, 0. So we're going from 0 to 800 with 5 subintervals. And so it's the B value minus the A, which is 0, not always 0, and then divided by the N. So there's our delta. And 5 intervals. Your first X is always the A value, so 0. And then you just add the previous to the delta X. And f of x, this is the formula that's given. Make sure you count all those zeros, there's a lot of them. That's squared minus that plus 45. So there's the f of x. Copy and paste however you like. Add those up. Do the Riemann sum. And is that the answer? Are you going to write down $23,302.40? Or are you going to make sure and look at the units? So our original function is given in cents, and our question is asked for in dollars. So how many cents are in a dollar? So the answer to part A, estimate the total cost $233.02. And then the next part, I'm going to do my best to do it in Excel and not handwrite it, but it is the initial value problem where we don't have a fixed cost. So technically not an initial value because K is going to be 0. But we're still going to do the antiderivative, and then we're going to evaluate it so that we can compare it in part C with an error. Okay, let's see. Part B. So what's the antiderivative going to be? This is just a polynomial, so it's the anti-power rule. So I'm going to add 1 to the exponent. That gets me a 3. And then I'm going to divide by a 3. Now, Excel knows what's going on here, but if you are not sure, then you can always put your parentheses around that, or you could put the divide by 3 up front. There's different ways of doing that. So it doesn't matter. And then the next term times x, add 1 to the exponent, divide by that, and then the last term would get an x like that. And we're evaluating when they're 800. And remember, that's in pennies. So our answer with the antiderivative and no fixed cost is 197.87 cents. And the answer in part A was an estimate of $233. So let's do our error. So this is going to be our estimate minus the actual that we got from the antiderivative and divided by the actual amount right there. And we're going to change it to a percentage. And not dollars. So percentage. Like that. So our estimate is about 17.77% higher than what the actual amount is. And that's the idea with the Riemann sum, is that if we increased the intervals, if we did 50 or 500, then our answer would be even closer. But sometimes an approximate is good enough.